Okay, in this video we're going to talk about solving and graphing inequalities. First thing we need to talk about is what is an inequality. So an inequality is just an equation, but instead of an equal sign, it has a greater than, less than symbol. We also have these things called compound inequalities, where you can have two inequalities with the word and or the word or that joins them together. Okay, and we'll talk about those a little later. First things first is we need to look at the different types of inequalities. So the first one we're going to look at is x is greater than 4. Okay, so this symbol here is a greater than symbol. Okay, and so you read that as x is greater than 4. Now to graph that, you find 4 on your number line, and this is actually going to be an open circle. And the reason it's an open circle is it does not include 4. It's everything bigger than 4. So we are going to shade everything that is bigger than 4. The next one, x is greater than or equal to 4. This symbol right here, that means it's equal to. So the only thing that changes on our graph is now, instead of an open circle, we have a closed circle. And we still shade everything that is greater than 4. Okay, the next one, x is less than 4. So again, it does not have an equal to, so it is an open circle. And we shade everything that is less than 4, so it's all this stuff. X is less than or equal to 4. The only difference is instead of an open circle, now it's a closed circle because it does include 4. Okay, so that's what those graphs are going to look like. That's how we graph inequalities with one variable. If we have two variables, that's a whole nother lesson. Okay, so now we need to talk about writing an inequality from a sentence. This can be tricky, but I have given you a worksheet that has a bunch of math words on it. So if you look at that, so if I look at example 1, 5 fewer than a number is at least 12. So let's underline some keywords. The number, or the word is, that's important. That means equal. So right here above it, I'm going to put an equal. Fewer than. So fewer means subtraction. Than, that's that turnaround word. Okay, so we have this number here, 5, and a number. Because this word than comes before is, these will switch places. So if we're talking about a number, we're just going to use a variable. So I'm going to use x fewer than 5. So fewer means subtraction. So you have x minus 5 is, so the equals, at least 12. So if it's at least 12, it can be bigger than 12, but it cannot be smaller than. So that's where we have this inequality here, greater than. So this side of the inequality has to be bigger than or equal to 12. Okay. Now number 2, the sum of a number and 5 is less than -7. So we have the word sum, which means addition, a number, and 5, those are the variables and numbers that we're going to be working with. Is, there's that is word, it means equals, less than -7. So this less than comes after the word is, so it's not a turnaround word. Less than just means less than -7. So the sum of a number and 5. So a number plus 5 must be less than -7. The last one, the quotient of a number and 3 is no more than 15. So quotient, that means division. A number and 3, those are what we're working with, is no more than. So it cannot be bigger than 15. 15 is the max, okay? So that means that everything else on this side, so if I have a quotient, I have divided by, so x divided by 3, everything on this side of the inequality must be less than 15. So we have less than or equal to. So it can be 15, it just can't be more than 15. Okay? So these can be a little tricky, but try those 2 practice problems on your own. Looks like this. So these words mean math, okay? And so a lot of them you've already heard, you know, sum means add, difference means subtraction, product is multiplication, quotient is division. Big one I want you to see here is the equals, is the word is. And then you have these things called turnaround words right here. The word than and from. If these words come before the word is, or whatever means equal to, then what happens is we have the x, or the numbers, they actually switch places in the equation. Okay, so we're going to look at that here in just a second. So now we're going to talk about solving and graphing inequalities. Okay, so if you can solve equations, solve for x, solving inequalities is not much different. The only thing you have to look out for is whenever you divide by a negative number, you must flip the inequality sign. Okay, and this first example is going to show you exactly that. So like we would solving regular equations, distribute first. So I have negative 6x plus 15 plus 1 is greater than or equal to 4. Simplify a little bit, negative 6x plus 16 is greater than or equal to 4. Okay, now go through your steps. Subtract 16 from both sides. 4 minus 16, that is negative 12. Now we divide by negative 6. This is the tricky part here. If you divide by a negative number, now this inequality symbol, it's no longer greater than or equal to, it will be less than or equal to. Negative 12 divided by negative 6, well, that's 2. Okay, so that's your answer. To graph it, you just create a number line here. Call this 0. And I'm looking at 2. Now it is an equal to, so it is a closed circle. Now x must be less than. So everything less than 2, that's what you shade. So that's your graph. We'll try this next one here. 8a minus 15 is greater than 73. Again, go through your steps. Add 15. A is greater than, well, 73 plus 15 is 88. Divide by 8. A is greater than, now the sign doesn't change because we didn't divide by a negative. 88 divided by 8 is 11. So to graph this, you might have to make a bigger number line here. I'll start my 0 way over here. Okay, it is an open circle because there is no equal to, and the variable is greater than 11, so you're shading everything that is greater than 11. Okay. Number 3, we'll distribute first. Negative 2w minus 8 plus 9 is less than negative 11. Combine your like terms. Negative 2w plus 1 is less than negative 11. Subtract 1 from both sides. negative 2w is less than negative 12. Divide by negative 2. Now remember what happens whenever we divide by a negative? The sign flips around. So now it's w is greater than 6. To graph that, create your number line. I'm going to start with 0 way over here. It is an open circle because it is not equal to, and we want everything that is bigger than 6, so everything this side. Okay, now try number 4 on your own. So pause this video and then I will have it worked out. Okay, so if you try number 4 on your own, you should get x is less than or equal to 8, and that is what the graph should look like. Okay. Okay, so now we're going to look at no solutions or all real numbers as solutions. So one thing to keep in mind is that whenever you solve, this especially happens whenever you have variables on both sides of the equal sign, if you come out with a statement that is true, so for example, that 0 is less than 1, that is a true statement, 0 is less than 1, then you have an infinite number of solutions. Okay, notice how there's no variable in there. Okay, if you come out with a false statement, such as 0 is greater than 1, there is no solution. Okay, so true is an infinite number of solutions, false is no solution. So what you're going to do is you're going to solve these equations just like you would a normal inequality here. We're going to distribute. So I have negative 6x minus 2 is greater than negative 6x plus 7. Now I want my variables on one side of the inequality, so I'm going to add 6x to both sides. Now whenever I do that, that goes away and that goes away. So I've eliminated my variable. All I'm left with is negative 2 is greater than 7. Is that a true or false statement? Negative 2 is not greater than 7. Therefore, this inequality has no solution. If we look at number 2 here, go about the same thing, distribute, so I have 10x minus 15 minus 7x is less than 3x plus 8. Okay, 10x minus 7x is 3x, minus 15 is less than 3x plus 8. Okay, I want my variables on both sides, or one side of the inequality, so I'm going to subtract 3x. Now whenever I do that, my variable goes away. I have negative 15 is less than 8. True or false? That is a true statement, so this means you have an infinite number of solutions. Or you can also say all real numbers are solutions. Okay, so that's all this means. True statement, infinite solutions. False statement, no solution. So now let's talk about these compound inequalities. If you remember from the very first page of the notes, the compound inequality is two inequalities with the word and or the word or that joins them together. Okay, so you can almost guess what the graph is going to look like just by how it's worded. So up above here, if you have an and statement, that means that the shaded area is going to be in between those two dots. If you have an or statement, they're going to be pointing in the opposite direction. Okay, so for example, number 1, what is the solution of 7 is less than 2x plus 1 and 3x is less than 18? Graph the solution. So you can guess, since this is an and statement, that they're actually going to be facing each other. So what you're going to do is you're going to solve each of these separately. Okay, so If I start with the first one here, I'll subtract 1 from both sides. That is a less than. Divide by 2. You get 3 is less than x. And over here, if we just divide by 3, you get x is less than, what's 18 divided by 36? Okay, so x is greater than 3, but less than 6. Okay, so if you were to graph that, so no equal to, so they are both open circles on 3 and on 6. So x is bigger than 3, so that means that everything bigger than 3 I'm going to shade that way. And x is less than 6, so everything that way. So notice you shade the in between. Okay, so that's an and statement. You can also write this answer as one inequality here. So you know that x must be less than 6, but it also has to be greater than 3. So you can combine them like that if you want. If that's too confusing, don't do it. If I look at number 2, what is the solution of 7 plus k is greater than 6, or 8 plus k is less than 3? So in the or statement, you can guess what it's going to look like. They're going to be facing the opposite direction. So if you solve for k, subtract 7, I get k is bigger than -1, or over here I'll subtract 8, I get k is less than -5. So if I were to graph this, we're talking about negatives, so I'm going to put my 0 over here. 1, 2, 3, 4, 5. No equal to, so they are going to be open circles at -1 and at -5. So k must be less than -1. Or I'm sorry, k must be greater than -1. Didn't quite make sense to me there for a second. So k must be greater than -1, so I'm shading everything that's greater than -1. Or k must be less than -5, so I'm shading everything that is less than -5. Okay, so that's how those work out as well. And that's solving inequalities. If you have any questions, let me know.